So for this one, but the thing that struck me about the discourse is that like it made it so much of like
Jag bad honom stänga sen, men han vill upp lite för att liksom att folk ser.
Testing.
stämmer det bra?
Det är bra.
Anybody is expecting chemistry stuff in here? Because the rooms were switched. So just in case, the chemistry session is in the other room.
And that's why this is going
That makes sense.
Oh, Christian, you've had a name change.
Oh yeah.
Yep. It's not us, in fact, it's the commission that kind of proposed the change.
There you go, Christian.
What is the name? Oh. Yeah.
Jo, han mejlade.
La prima è quella del disegno della federazione, poi sui grafi in generale.
È quella su primo il cambio c'è il cambio del nome, poi c'è l'introduzione, è quella tipo con siamo tanti quelli sa con tutto il cono.
Allora magari se mi dai quella, parto solo con quella, poi fai così c'è un po' di contenuti.
Ricordati, la prima è il cambio del nome.
Is the remote working?
Yes.
Su cosa pesa una tonnellata?
Do we need? Are we using those? Yes. That's the battery one. This has better audio. That's why. But if someone wants to talk, just ask them to hold it close. This one's a little bit lower. But yeah, they're all both.
If you forget, we will give you a friendly reminder. Hopefully.
You throw me the microphone. It's like the Thor hammer. Questo è principale di mano. Veramente notevole. Credevo rimettessi a posto la stanza come visionato. Chemistry section is the
Have you checked the chemistry session? Oh, okay. How long? Did you ask in the other session? I'm sorry here because the other room is what's listed on the room.
but they know. We just
Both sessions are listed as in the room.
They know. Many people actually conduct it.
in multiple locations, Mike?
No, this session is and the chemistry session are both listed in that room.
Oh.
So they both got the same event.
That could be a problem. So in one of them, I know in the one that Suzanne looked like it was correct, it was correctly here, but some of them that are listed in both, some have it here.
For the last occasion, this is open science graphs. Chemistry is in the other section. Just in case. It's 1:30.
Yes.
Can we wait 2 minutes for the Italians and the Greeks? 5. No, 2 minutes. Qui devo anche parlare qui dentro. Okay, so I think we can get started. Thank you all for filling the room, filling it up. And so this is a session on open science graphs. There's a missing S there, but the idea is that we are working on this topic. And of course, contributions are extremely important because this is becoming a rather important and central element, the one of constructing graphs to share metadata and information about scholarly communication in general. So the group is led and co-chaired by Sarala, Wimalaratne, Amir Piani. Sarala works for DataSite, and Amir is from Swinburne University. In fact, is behind the realization of the research graph in Australia. And Andrea is from CNR, and I'm Paolo from OpenAir and CNR at the same time. So first of all, doesn't work. Okay, it does. There's been a change in the name. So when we started this work, since we are working in open science and we are into there and we've been into there for so many years, we had to find a name and we called them open science graphs. So I will tell you what they are in more less than intuitively later on. But the Commission started making a lot of fuss about them, and we have a lot of programs and a lot of calls that are referring to scientific knowledge graphs today. They call them SKGs de facto. So we decided to follow the trend, not to be ambiguous, to be clear about the message that we are delivering. So a little bit of housekeeping here. If you use your mobiles, you will find a way through the minutes and how we would like to follow up with you with feedback and etc. Everything that you found so far in RDA. So contributions are important. Be active, write what you think while we speak, and feel free to offer intuitions, initiatives, ideas. Now, to introduce the setting for those who are not very familiar with it. I bet all of you have heard about them, but this is a bunch, not all of them, of the so-called scientific knowledge graphs that we are working on every day, even without knowing sometimes, because they are powering many of the tools that we use. And sometimes more directly as researchers, because we want the data that they share and we want to use. Okay, so each of these has a different story, was born to serve a very specific domain or a specific set of applications. You may think of, I don't know, Scholar is one that you use a lot. It is a graph. Why it is a graph? Because it is a set of connected entities, like authors that are connected to papers, that are connected to organizations. Papers are connected to conferences and so on. So you can build what mathematically is known as a graph. So edges that connect nodes of different nature. So each of these is now part and forms implicitly a large ecosystem, thanks to some infrastructural assumptions that we're making, for example, persistent identifiers. Many of these graphs refer to these very precious numbers, unique numbers that connect things magically, implicitly. So whenever you're using into your little drawer or your little desktop an identifier, de facto you're connecting your statement, your facts, to anybody else that is using the same persistent identifiers. So this is actually key in this domain. Then there are other many and multiple assumptions that we're making in the way we represent the entities that are core to these graphs. For example, publications. Publications like articles, theses are described with metadata formats that are now quite common and used across many of these initiatives and implicitly share the elements and the properties in a very common way. Still, not the same way. Finally, all these serve different applications. Discovery typically, or monitor, assessment, evaluation of science. So they have different purposes and they have different business models inside. And also business logics. So you may find super expert in a domain somewhere, and you may find less experts in other domain. So each of these graphs brings something new and important, very focused with very specific skills that others may not instead deliver. So what is important, and what Andrea will now follow up with, is that we really need to connect those using a common language, using a common understanding, and trying to explain what they deliver in detail, so that if I am a user of those graphs, I'm able to decide and understand which are the best for me. Which are the data sources behind? What am I doing with these data sources? How am I cleaning them up? How am I connecting the dots? What is a publication for me? This is very important. So this is the work and the objectives of the objective of this working group, interest group, that will soon become a working group. And we are trying basically to make some cleaning and understanding in this very diverse and heterogeneous world. So Andrea, for you, keep this weight in your hand.
My oh my. First disclaimer, I accidentally canceled datasite / pitgraph this morning. I'm sorry, guys. Yeah. So thank you, Paolo, for the gentle introduction. So this is basically what the idea behind what Paolo was saying. Like, it would be nice to have all the SKGs to kind of talk a common language, so that they can capitalize on synergies and complete each other to some extent with missing information, which is an added value that's available at other places. And so to this extent, we think that like it was reasonable to introduce an interoperability layer to make this kind of translation, to make this kind of seamless flow of information possible. Everything started in RDA P19. There was virtual in Seoul, and from June 2022 we started. We kicked off with a timeline of task forces, and at the moment we are wrapping up with task force 3, and so we went through basically scouting process of all the information models that are locally available at different SKGs initiatives. We analyzed what they have, what kind of information they expose, what kind of information they model, how and how, which are the commonalities, how can you put different things to a common factor. As Paulo was mentioning, we are transitioning into working group because supposedly we are intend to deliver something. So the working groups within RDA is the best place to achieve this. And I submitted a case statement in February, and today the secretariat told me that they had a tab meeting and they are going to provide us feedback by the end of the month. The board is composed by me, Jason Prim from OpenAlex, Silvia Peroni from Open Citations, and Sahar Badati from the Inf AI Institute. So task force 1 was about SKG's core information model. And as I was saying, like, so we started charting different models, different initiatives, and we tried to survey which were the standards, de facto standards, and ways to model this information. We are going in a incremental fashion, so we have an iterative process. We never settle, and we are actually in an ongoing discussion about certain aspects. I will tell you later. And so basically, we started to set up a huge spreadsheet, trying to put tick boxes, tick marks, whenever a scholarly knowledge graphs was modeling a kind of concept that maps onto scholarly domain. And these ones, the one you see here, are the entities that are that we found persistently repeated over and over, which is reasonable, but you know, like there are other modes that are actually not on hold at the moment. So for the time being, we focused on research products, obviously, authors, researchers, organizations, venues, which can be journals and conferences, and more. I will specify a bit better these later. Topics, projects, authorship, meaning the affiliation of an author participating into journal, and affiliations as ORCID models them. So basically like the lifetime affiliations of a certain individual. There are also entities that are actually on hold, and like such as patents, publishers, and services, workflows and protocols, instruments, facilities, and research objects. So these ones, we didn't find them adequately represented in the SKGs that we analyzed. So we put them on hold for the next iterations to come, to see whether we can do something about this. So the data model so far encompasses 9 entities, namely organizations, affiliations, researchers, authorships, products, topics, and publishing venues, publishing venues, data sources, and projects. These on the far right end, the distinction between publishing venue and data sources it's something that's that we are discussing at the moment, and it has been introduced when, Paolo, like last month. No, it's something that derived from an extensive discussion we had. I mean, it was something that was going around in the air among us, but talking with Jason Priam a few months ago, it was, I think, the epiphany, and basically it's something that's demanded mostly by research evaluation within open science, because with open science there's the gatekeeping kind of is jammed. So like people can put can deposit artifacts, research products at their own will, and whomever is assessing research activities has to need some kind of quality assurance on whether the data set, the software is actually viable for being evaluated. And this is, I mean, comes from real life examples. Like we had a user trying to do basic search on our portal and on OpenAir, and at some point a figure popped up, and this was like a figure, meaning a figure included in a paper, was marked as a data set. And this is like that because there is a publishing workflow behind it that posts that figure on Dryad. And this happens for all the papers published by this publisher. And these are marked as data sets, but of course, like they shouldn't be taken into consideration when doing research evaluation. So what we are trying to do here is distinguish the researcher intent with respect to publishing. So that's the publishing venue where the person decides to publish their work, and data sources, which is where we get the metadata from. And I'm saying as aggregators of OpenAir, as aggregator of metadata. So do you want to add anything else, like more or less? So that's the main distinction. I hope it's that is clear. But basically, what we want to say is that publishing venues do have some kind of quality assurance, like they do peer review. They, at least like they do some kind of peer review. They might do or might not do data curation, while data sources are basically like containers, like or repositories, like Zenodo or Archive. You just put a paper inside there, and you don't have any consuming the metadata about that paper doesn't give you any assurance on the information that has been deposited. So there are lots of open questions, and this about the distinction about venues and data sources I was just talking about, and also about there are other relationship that should be introduced, as this one here, data side semantics between, so this self relation of products. That in data side there's a vocabulary for relations, so that you can put different products in relation to each other. So like is part of is sequence. This figure is part of a data set and is followed by this other one, and so on and so forth. So we are thinking to introduce these in our model, and we are speculating on whether to follow blindly data side scheme on these kind of relations, or whether we should adopt a subset of these relations. About venues, this yeah, I mean, here it's depending on where people want to publish, we have different choices on how to model different metadata. So like journal issues and journal volume are venues, products, and the product. So the paper is the only one that maps onto, or chapters is the only one that map onto product. Task Force 2, again, wrapped up in February. And we have been surveying the metadata formats and that are available for the entities. And we define crosswalks between different data models to the common one we defined. And again, in the same spreadsheet, there are other huge tabs where we try to map all the for each entity, we try to map all the properties and the relations and how these map onto different different data models. Task Force 3, it's has been ongoing in this month, and it's about how to technically achieve what we are trying to do here. And that's just initial thoughts. I think we are a bit behind that, but I mean, we had a quick discussion, and I don't feel like we are yet finished with that. We just started, but yeah, I mean, it's like there was, let's say, consensus about around JSON and JSON LD, and there was again kind of consensus on let's start with data down. We can have whomever is going to adopt this interoperability framework first to of information, and then in the second stage to have a REST API to selectively query and export artifacts. Artifacts, metadata. I mean. Then there is this Task Force 4, which is about profiling SKGs, which is basically a way to have to put up a catalog. Oh, there's the old OSGs. Anyway, typos. A catalog of SKGs where basically you can find high level machine readable and human understandable informations about the SKG at hand. For example, the compliance level to the interoperability framework, supported entities, the adopted PIDs if they are adopted, otherwise local identifiers, the schema that the data is supposed to follow, protocols and license for accessing the data, documentation, provenance, and added value, and software and algorithms that are locally used to process the data to do some enhancement, for example, deduplications of entity, topic extraction. So to have pointers that tell you this SKG is doing this, and that, so that there's transparency and accountability for the processes that are locally performed to put together the data that the graph is exporting. We started not many days ago, I would say, to process what was in this spreadsheet I mentioned before into README documentation, and so it's work in progress. But yeah, I mean, we will get there also, because by the end of April there's a first deliverable according to the timeline that we specified in the working group case statement, and this is going to be part of it. Well, it's going to be it, yeah. Full stop. So next day, we're going to have 3 presentations. Well, are you covering Amir? Because you couldn't make it. And so Arcangelo is going to be the first one. Then Christian from data side follows, and then Paolo will do the. We'll do how's it called? Present as Amir. Impression, an impression of Amir Roriani. And then we'll follow with an open discussion and brainstorming on challenges. So it's a full house, so we hope to have nice feedback from you all. Yeah, this is afterwards. Yeah.
Arcangelo is from University of Bologna. He's representing the presentation because University of Bologna is the actual provider of the service.
Thank you. I work as a developer at Open Citations at University of Bologna. And in this presentation, I will outline how we intend to adopt these scientific knowledge graphs interoperability framework and the challenges that we will have to face. Yes, that's the one. Okay, so before going into the technicalities, I would like to introduce you Open Citation as a scientific knowledge graph. Open Citations is an independent infrastructure organization dedicated to open scholarship. We publish citation and bibliographic metadata in CC0, public domain, by the use of semantic web technologies. And we are engaged in advocacy for open citations, open bibliographic metadata, and open abstracts, particularly via the Initiative for Open Citations and the Initiative for Open Abstracts. Currently, we provide our data model, the Open Citations data model, which is based on the SPAR ontologies, and 4 citation indexes, which are COCI, that derives citations from Crossref, Doki from DataCite, POCI from PubMed. Yeah, they are like the 7 dwarfs. Now we have 4 of them. Then we will have Joki from Japan and so on and so forth. And then we have Croki, which is, yeah, Croki is the one that contains citations harvested via crowdsourcing. And finally, recently we introduced Open Citations Meta at the end of December last year that contains in-house the bibliographic metadata of all the documents involved in the citation contained in the other 4 indexes. All the software to release, produce, and maintain such indexes is open source on GitHub under open licenses. And you can access those data via RESTful APIs, Sparkle endpoints, data dumps, and web interfaces. Okay. So in order to deliver such data according to the SKG interoperability framework, we are planning to write a cross-wall document that will map all the classes and properties of our metadata schema, which are relevant for the interoperability framework with the interoperability framework itself. And this document will be used with a twofold purpose. So the first step will be to immediately deliver the data according to the new data model via the APIs, via real-time conversions. And the second purpose will be in the second phase to provide the data dumps natively according to the new model. So Open Citations implements API via RAMOS, that stands for the RESTful API Manager over Sparkle endpoints, which is an application that enables agile development and publication of documented RESTful APIs for querying Sparkle endpoints according to a particular specification document. Now, currently, via this system, the user can select 2 output formats, which are CSV and JSON. The idea is to provide a third possibility, which will be SKG, specified via a query at the end of the API request to get the data according to the new model. And this can be done easily as a first step to immediately provide the data according to the new model. Now, regarding the entities Andrea previously showed you, not all of them are relevant for Open Citations. We just have the data regarding research products. We model them via the ontology Fabio. They are Fabio expression, venues, which are still Fabio expressions, authorship and organization, we consider them as roles. They are described in the publishing role ontology as pro-author and pro-publisher. And then we don't have information about topic, project, and data source in our data. Two notes, one regarding affiliation and the other regarding data source. We theoretically could model affiliation via the scholarly roles ontology, but we do not have such data. So even if such entity exists in the SPAR ontologies, it is not in the Open Citations data model for that reason. While regarding the data source, so to recap, the difference between venue and data source is that the venue is the place where scholars decide to publish their outputs, while the data source is the infrastructure, the repository that actually provides the metadata to us who harvest them. We describe the data source not at the data level, but at the provenance level via proved primary source. So probably it won't be described according to the interoperability framework model. So in this first step, we will map the entities to those of the interoperability framework, to those of Open Citations which are relevant, and we will use generic ones where we do not have a perfect match. While in a second phase, we will extend our data model to include those classes and properties that we have data on, but we do not have modeled them semantically. So for example, the interoperability framework will introduce a new kind for us at least, of publishing venue, which is a repository, which we now model as other generically, and we intend to add it and eventually others which are relevant. Thank you.
Thank you, Arcangelo. So as you notice here, we have a very good example of how the construction of such an interoperability framework can somehow affect, in the good, in the pros, and in the cons, somehow the local infrastructure, right? So in a way, you may adapt your local infrastructure to match such things. In another way, to match the model. So, and actually this is a choice from them. And in another way, you may not have the information that is requested by the interoperability framework. Of course, it's a general problem that we all have when we are mapping onto a model, so we shouldn't worry about it, okay? But ideally, it would be nice to identify common patterns on what I have to do if I don't have an explicit entity that maps into the data model, but I rather have properties of my entities that map onto it. For example, I don't have ORCID identifiers, I only have author strings. How am I supposed to map my authors into such a model? This is another topic open with suggestions already. So the next speaker now is Christian. Thank you from your side.
Yeah, I think that one. Thank you. Okay, thank you, Paolo, everybody. Well, I'm going to talk about the PID graph, which is another scientific knowledge graph. I got that right? Maybe I put the science knowledge graph. I'm sorry. My name is Christian Garza. I work as a product design manager at DataCite. And for those of you who don't know, DataCite is a global provider of DOIs for the research data and other scientific outputs. Oops. Is that? Yeah. For those of you that don't have don't know much about the PID graph, I'll do a little recap for people that are new in this meeting or this group. And then I'll go like it was done in the previous session to go and discuss how the results from the task force could be implemented into the PID graph and all of those results. And okay, there you go. Yeah, yes, that's fine. So the PID graph consists of an interconnected web of digital objects and their relationships. This is created with persistent identifiers like DOIs, ORCIDs, and ROR IDs. So by specifying the relationships within the metadata, With the metadata, we create a trail of connections for both humans and machines to follow. This graph, we believe, offers a broader perspective on the research data and its usage and interactions. Trusted sources are the ones that provide source relationships. Crossref, DataCite, ROR, and ORCID provide these web digital objects in the relationships that are embedded in DUI metadata, and that's where we get everything. And so the membership of these organizations are the ones that supply all the data that we put in the PID graph. The PID graph currently includes millions of datasets, articles, well, nodes that represent million datasets and articles, people, organizations, and funders, and we have several ways to access this PID graph that includes a web interface that we call DataSite Commons, which addresses specific use cases for researchers and data repositories, but also in that interface addresses specific use cases like go to see everything that's connected to a research work or a person. So all the information of the PID graph is described in a GraphQL schema that defines all the hierarchies and connections between between nodes in this PID graph, and that schema powers a GraphQL API, which offers another window into the PID graph, and allow users to access it in a programmatic way without the restriction of the UI might have, so you can make richer questions there. I must say also that there are many other APIs to access that, like the Scholarly API that is part of Crossref and is currently Crossref. So, I mean, in summary about that recap of the PID graph, I mean, it consists of nodes identified by persistent identifiers with metadata and relationships provided by trusted sources, and the information that we have there, we describe it with a GraphQL schema, and it's accessible in several different formats. That's in 5 minutes or 3 minutes, the recap of that. Now for this talk, for today, I mean, the discussion is about this crucial task or looking at the results of the task forces and see how can we implement that into the PID graph and address the use cases that have been described in this working group throughout the years or through the different sessions. So I'm going to give you an initial assessment of what we have been looking in these results of the task forces and what we are planning to do. And let me clarify that we have not yet completed this initial, well, we started this assessment, but we have not completed. So, however, I will mention what initial thoughts. So as I mentioned, well, there are the PID graph has identifiers for all these nodes with persistent identifiers, which is important for traceability and ensuring reliability. Includes a variety of entities that are already in the interoperability model, like organizations, funders, etc. And upon examining the entity model, we are optimistic that we can find compatibility with any entity with a PID. So that's the kind of the scope of this. So we are able to map entities to that model, provided that there is a PID on those ones. We still need to do a further examination for entities that don't broadly use PIDs like ORCID, TOIs, RODs, etc. And that probably presents a challenge for us to ensure the completeness of the graph. I mean, to expand it to something bigger. And I will talk a little bit about how we plan to address that later. We also need to do a study of the crosswalk. We have not started that. And also take decisions between what schema we are making the crosswalk against. I think the initial document uses that as a schema, but I think internally we have questions about whether to use also our GraphQL schema to make this crosswalk. So it's something that we internally need to still discuss and decide what are we going to do. So practically, with regards to task force 1 and 2, there are initial steps, but we still have to work on that part. Now, with this information in mind, we have a plan of how we plan to address different use cases that this working group has been highlighted over the years. I'm not going to go through those use cases, sorry, but there's not much time. But if you go to past plenaries, you will find a full description of those ones. But what I want to do is to show plan of how we are going to try to address them. So directly to the gist of the thing. As with open citations, we are planning to implement services that help to generate data dumps of the PID graph, both the relationships and the objects, to provide a comprehensive view of the current status of the current state of the graph. But also, we believe that this will enable interested parties to get the graph and study it and find ways that can be improved, but also whoever wants to integrate with the graph. Next, we will work also on allowing other trusted sources to provide assertions into the graph. I mentioned some of them already, but we want to allow other sources to provide that and incorporating a variety of more sources, more trusted sources that will help us with that item that was highlighted by the first task force. And lastly, we also want to focus on what is practically part of task force 2, that provide compatibility with other graphs and implementing these crosswalks. We think that will ensure that our graph can be effectively utilized with other graphs that are out there, as it has been pointed out. I put a link to a roadmap there and it's an item for all this work there. And we also, all of this, we are doing it in the framework of FairCore for EOS as well. So there is overlapping tasks on here. I think, in general, the only thing that I want to assure is that we are truly committed to analyzing the results of each of the task forces and looking to implement that to address the use cases. Yep, I think that's it.
Thank you. Thank you. This yeah, the third. Yes. So I'm Amir. We'll never be able to be as good as he is, but we'll give it a try. Okay, yes. Okay. I don't remember by heart the slides, so we'll just go one by one. But anyway, thank you. Yes. So Amir has been working on this initiative for almost a decade, since I met him the first time, actually in an RDA conference, if I well remember. The whole idea. Now I'm waiting. Is it 2 or 1? Because I would turn my head. Just 1. Go back. Okay. It's fine. Okay. So the Resource Graph Foundation is an Australian initiative. So it started with the motivation, as all these graphs do. Okay, they have a mission to accomplish, and the mission has always to do with collecting data from different sources, bringing them together for a reason. The reason here was that they in Australia they developed, of course, as we all do in all our countries, a federation of data sources. They started working on data and research data, a federation of repositories, and the problem there was that these were misaligned. They were having common assumptions, like using common identifier systems at the national level, but in a way or another, they never put them together to find out which are the possible networks that may arise from this implicitly connected world, but without nobody bringing things together. So what they did with the resource graph, it was exactly to start this exercise. So collecting metadata from different sources and mapping them into a common model. The model, I'm not sure you can read it, but we have a researcher here at the top. We have research data, we have organizations, we have grants, which play a crucial role in all countries, but of course also in Australia, and publications. So they started building this network of connected objects to play with it and identify collaborations, identify relationships between organizations and researchers, identifying which were the grants and tracking, for example, which grants were playing a common and effort and role in the developments of different organizations. And they were able to do this thanks to this graph, which is now a production service and part of the national services for in support of the data. So they are including now software and patent. They were focusing a lot in the beginning on the wave of open science, let's say, on the introduction of data, because they had publications very regularly stored and record it, and they introduce data set. And now they're moving to software and patent, which is something we are also doing in Europe. You know, the EOSC and all these efforts, OpenAir included, many of the graphs that you've seen before are now moving beyond the publication. So they're trying to include other kinds of products. Very optimistically thinking that this is an easy process, but we'll talk about it later. And so the same these guys are doing with new properties like journals, is a venue, topics, conferences, venues again, and publishers in general. So this is the last slide from Amir. So they're working, of course, together with us on this working group. They're co-chairing it, in fact, and they're contributing to these mappings. And the idea is that this is what they will gain, which is a very general statement you can apply to all the graphs involved here. But in their specific case, I think what is important is that they can gather information that is may be provided by other graphs worldwide in a very easy way. So to have their workflows nicely shaped to include any sort of graph that respects this kind of model, to improve what they have at the national level. Okay, this is a typical relationship between global scope graphs and locally scoped graphs. Vice versa, what we can learn from a graph like the one of Australia, and this is, I think, a process that we should apply, and we are applying in Europe, for example, with, where is Tommy? With Tommy in Finland, is that typically national graphs are highly curated in many ways because they're used for local evaluation, they're collected from via agreements with the universities, they have regular processes. And so this gives us cleaner information, which is extremely precious to build these globally scoped graphs. Okay, so this is a give and take that we hope this kind of federation that we are enabling now will actually help us to do. Okay, so Andrea, I think we have a little gaming
drinking game. Back to almost done.
Almost.
Yeah. This slide, yes. Yeah. So we have this Mentimeter up and going. You need to go on to launch it. I think go. Yeah, you need to go on. So no, go on Chrome. There is a anonymous session there. Present. And you don't need to share this one. Yeah, okay, yeah. True that. It's working. Yeah, let's wait people to. How many are we? 70. Okay. Plus 40 online. Okay. Wow. That's 70 here plus 40 online. It's I think is a record in our history. Okay. Let's move. Okay. We can go. No, just click if you on this open the tab.
I click the tab to this.
Okay, just you need to give the focus there and then press right. Try. Yeah. So, which sides of the fence do you stand on? Are you consuming, producing SKGs, or just passing by? Okay. Bystanders. I hope we steer interest of newcomers. We converged. Okay, it's good to know that there are many people that never interacted with SKGs that actually are interested or happen to stumble on, or, yeah, indirectly, you know, like it's a good. I'm happy I put the third option because I had the feeling that it could be, it could tell something. Okay, next one, right on the. So you engage with scholarly knowledge graphs as a bunch of categories. Multiple choice.
Is it multiple? Okay.
Uh,
Just pick your favorite. It's fine.
Bummer. I thought it was, yeah,
I mean, it's already good to know what's there.
yeah. We have a policymaker. That's a first timer. Two, actually. Okay, never engaged so far. Makes sense.
Proportional.
Yeah. Lots of service providers,
Yeah,
which
so the providers here and online, please contact us.
yeah. Because I mean, SKG providers, that makes sense. We know each other, and so it's friendly faces around. But and what is interesting, and what I added this time is research evaluators, which would be nice as well to know how they engage with scholarly knowledge graphs in the first place. To raise your hand and identify yourself now forcibly, but if afterwards in the open discussion you want to tell us how you use our data in your evaluation process, that would be nice. Funders, yeah, we know. And yeah, and nice
Also
picture.
developers.
And other is the other thing. Like, I would like to know that what I didn't capture in these categories. Like, I would be very much curious to know what these three persons are doing. Next. Okay, so this is like voting this whole endeavor. Like what we are discussing here, like scholarly knowledge graph interoperability framework. So it's basically what we are doing. It's very refreshing that people think that feasibility is, I mean, it's above the average. I thought people would be like, no, it's never gonna happen. No, and relevance, and that's, yeah, good. And I thought that ambition would skyrocket to a solid 5, but no, yeah, okay,
It is reasonable.
grounded. Yeah, it was the. You can, I think you can reassess if is there. Okay. All ones. Okay.
So it's higher.
It's lower in the average. Okay, next one. And these are open questions. I think you have 3 alternatives, and
yeah, we have exchange formats and access protocols
in the next one. So if you have any queue, so this is basically if you are rather technical, if you have any direction that can help us in landscaping the activities, the future activities, in terms of that's honest. Oh, it's good that someone posted no, but XML, because in the documentation I started with XML, which I find no RDF, please.
That's the JSON LD, let's say, trick, because
Yeah.
it enables it in a way. So
Well, there's the other alternative version of JSON LD without the hyphen.
yes, we have 2 JSON LDs.
Okay, Serif. I see Serif flying around.
Where is Keith? He's not.
Something with the scheme. Lots of good luck. Lots of good luck and punch cards. Magic.
Okay, that's fine. I think it's stabilized.
That's the benefit of being anonymous. Okay, next. Something with a scheme. Can you, yeah, next. And access protocols. So we were settling for dumps and some kind of APIs that where you can selectively choose. Again, no. That's fine.
It gets bigger.
Okay. This is getting beyond our control.
So somebody's serious also, so that's quite well.
Yeah. Okay, REST API, the surfacing from the REST. Asking nicely.
Got out of hand.
Graph
Clearly,
actually.
okay. Okay, you're all nice, but some concrete answer would have been also useful.
Oh yeah, IPMH. Oh no. Okay.
We lost nicely. Okay.
Carrier pigeon.
Okay. Thank you. I actually prefer the results of the previous time. Thank you. Okay. So thank you. So we can open a discussion. So
There's if you go
great
back
to have your opinions,
to the
ideas, input.
back to the first presentation, I think there is another slide.
I know who's going to answer this time.
Yeah, the microphone.
Oh, yep. Sorry.
Sorry.
Okay. Please keep the microphone close to your mouth.
Wait a second. There's another slide.
Okay, thank you very much. My name is Jurgen Moers from Utrecht University. We're talking about let's ring to rule them all, but if you go for the local...
Can you stand? So
stand? Oh, yes, of course.
Because the microphone is only for those online, not for the room. Okay.
Oh, I'm sorry.
Okay. No.
I hope you can hear me. So if you are looking at this solution from an SKG, then how do you perceive still the local initiatives to start your own graph, right? So if you look at the institute level, then we are all gathering so much information in graphs potentially, but we are trying to build our own graph at this moment. So what's the benefit for the individual institute to do that at this moment? So is there any ideas on that, how we can perceive
so
that?
If I well understand the question, so of course you should build your own graph because you have a specific mission to accomplish there. Again, so at CNR, we are building a graph, my own institution, which includes entities that are not of general interest at all. We have notions like laboratories or whoever that are not really to be shared with the world. But once you're over with your implementation and you have delivered what you're supposed to deliver, of course, you have a gain in having easy ways to connect to other graphs. So to collect information that may enrich yours or to share your graph straight away through workflows that are based on common standards. Of course, you always need some further magic on top because, you know, data transformation is not easy, but counting on a common way to look at things is very important. Okay, I'll scream.
So relevance got a high score. So relevance for who then in this case?
It's a good question. Well, I would say relevance, I think, with respect to the current scenario. So what you're going to do, we have research evaluation, research assessment on the way, which has to take into account many different entities with respect to the past. So publications, data, software. There are many initiatives that are trying to align on the usage of persistent identifiers. Also the minting of persistent identifiers for entities that didn't have one before. We have the instruments, we have the tools, that is another ongoing activity. So we are trying to model a much better world in terms of what? In terms of monitoring, tracking, trends, history, and discovery, right? So relevance, I think, with respect to this scenario.
Thank you.
Tommy. Oh, sorry. Yes.
So I'm Joachim Philipsson from Stockholm University, but I'd like to take the stand of a grassroots bystander. So I would want to know, what would I have to do? Let's say I work among a small RDM staff at a small research institute, and I want our researchers to be part of this SKJG or the PID graph. And what do I have to do? Let's say our staff is not very knowledgeable about linked data or the semantic web. And is it enough that we see to that our researchers have PIDs from data site for all, or do I have to set up a Sparkle endpoint to be part of the remote?
You want to take this one?
Yeah.
I think you practically answered already the question. Yeah, yourself. Like, yeah, you need your researchers to use orchid IDs during your institutions and organizations to identify themselves with ROR IDs, and that the connections between those ones and DOIs for your data or articles, you are declaring DOI metadata when you publish a data set, or you put in reference lists when they publish a paper in a journal. And while you do that, automatically all the workflows are working for us to surface that, to open it, to harvest that, and other SKGs to take it and make it interoperable. Tommy?
We have Keith also in the other room.
Hi, so I'm Tommy Suominen from CSC, coordinating the Fair Core for IOSC project, but at the same time I have designed the information models for the national CRIS. Yep.
And you can hear it now because it's closer. But
yeah, so I want more. I'm not happy with this. The edges, for example, it's not enough to have an edge. I need verification, I need more information. So we have the 14 credit roles between a publisher and a person, article and a person. But for example, in our scheme, we have data sets, and then we have an actor that has a role to the data set, and we don't even know. That can be an organization who is the copyright holder or a person. We don't know which one. But for sure, it's not worth a lot if you have the connection simply that this entity is related to this data set. You need more information on this edge between those two. So I need much more verification. And to that extent, what if I add a connection between a person and a data set and I realize, oh crap, I made a mistake. But because all of these science knowledge graphs are linked to each other, and they're hungry for connection information, so they automatically harvest this new mistakenly entered edge. What is the mechanism to correct information if the edges don't have provenance? So these kind of things come to mind at first.
Yeah, no, of course. So this is a multiple question with multiple answers. So the first simple question, the first simple answer is the following. We are trying to be pragmatic. So we're not trying to model the perfect world, but we're trying to model what is available out there that can be useful to all, okay? Because if we start modeling the perfect world, we are building a super descriptive model that nobody will fill in the next 30 years, okay? And that's going to be useless. It's going to become something huge maybe inspiring, but not useful at all. Actually, in fact, it's going to complicate the whole process and developments behind it, the ones that we want to enable in a way. Provenance is in the plan, is in the second round. Provenance and trust, which is some kind of information that some of these graphs are already storing. For example, the OpenAir graph does. We know where every single object comes from. We know which is the algorithm that has produced it. We have a sort of approximation, and this is similar for others. Okay, so I think OpenAlex as well has information of this kind, where the information comes from and so on. And it's quite common to do it because it's useful for you to rebuild your graph. Then the third answer is that currently out there, the sources are not providing this information at all. Okay, so I can discuss about roles of authors, but there's nowhere a point where this information is being captured. Okay, so when this will be the case, when maybe ChatGPT 20 will be able to extract this information, then maybe will be the time also to capture it across graphs in a common way. Okay, so again, it's a balance of things. I agree. I would like to have more, but it's something that the community is not producing at all today. Okay. I have Keith, and there's one a question online about Scholix and Scholar Explorer. So, yeah. So Scholix is a format for the exchange of scholarly links. It's a result of RDA. It became a de facto standard, and now many initiatives are implementing it. But it's all about link exchange. So we have a source, we have a target, we have a semantic in between. We can capture a little bit beyond that, but it captures exactly that. So an idea, of course, is to reuse Scholix as part of this model to exchange in a structured way the information. It has to reflect Scholix. And Scholar Explorer instead is the service that we're providing as OpenAir that resolves these links in Scholar Explorer from our graph. So you may call Scholar Explorer our API on that, but event data, for example, for Crossref has a resolution API that does the same work on a different set, the one of DOIs, okay, only. So these are similar APIs with different names, with different kinds of content behind, because they're built again on different SKGs, okay. Keith.
Okay, thanks very much. I'm Keith Jeffrey, past director of the National Science Lab IT department in UK, now working on 5 different EC projects. Paolo will know what I'm going to say anyway. First problem, you indicate the relationship between a researcher and a product, researcher and a project is only through a product. That clearly is stupid.
Excuse me, there is the relationship
between a researcher and a project. Looking at your
data
model is
that's
only
a product and
product. So it goes researcher,
yes.
product,
yes,
project.
Yes.
There can be relationships between researchers and projects which don't involve a product.
Yes. We in fact infer relationships between project and researchers thanks to that, because they have their names on deliverables that are assigned to a project, but that's a different story.
Okay, and the second one is the relationship between the researcher and the data source, of course. And that brings up the point that the researcher isn't actually a base entity, it's a role of a person, and the person could be a manager of a data source, just as an example. So, and finally, I disagree fundamentally with your premise. I think you have to design a data model that represents the real world and populate it sparsely, because all my experience is progressively people produce more and more relevant information as they become more accustomed to the need to have a better information source to do all the things that we talk about, like evaluation, like generating web pages to advertise the faculty of a university, and so on. So I just start from a very different position.
Yeah, we often do that. But no problem. I mean, it's just a different position. There's many more probably in the room. So the first answer is, again, we want it to be pragmatic. So we're not including here all possible roles, but the role that a researcher can play can make a difference in terms of producing products. That's what it is. As to the other approach, the one where you want to have a big model that nobody, let's say, is able to fill in, we may have different opinions. For example, I work with SciDoc, which is an incredibly fantastic model, and all I get is a title and a date. And frankly, I have to build huge systems that take into account all sorts of peculiarities, and nobody uses them, not even 1%. And the whole cost goes in that. While if you go for a pragmatic approach, you spend $1 million less, and probably you can incrementally build something useful. So we need this tomorrow, not in 20 years, okay? So again, we went this path and you wrote this road because of that. Just a simple yes.
I mean, I agree with the points you raised, and I mean, I think that the divergence here stems from the fact that as SKGs, we start off from the aggregation of metadata from other parties, which are inherently research product centric. So I agree with you, like that would be the perfect model, and I would dream to have that up and going. But the reality, I mean, we need to model these in a pragmatic way, as he was saying, in this way, because we are consuming data that's kind of already captures this root of all the scenes, like that being research product centric. So, well, that's
You need to do some more searching. If you look at the databases of funding organizations, I only know the ones in Europe. You need to do a bit more searching. If you look at the databases of the funding organizations in Europe, I don't know the ones in other parts of the world, you'll find they have a lot more information than in your model. If you look at many universities,
Yes.
their administrative systems for keeping track of research grants and how they connect to publications and everything else, a lot more than in your model.
Yes.
So why be so scared?
But again, you have to draw a line. So that's the thing. So when you look at the map, the big map that we built, and how and what SKGs are producing today, what they are keeping inside, this is what is most relevant to them. These are the most common entities that they account for, and this is the SKGs, the existing ones: Scopus, Crossref, DataSite. So the big guys, right? So the ones who keep most of the information and knowledge out there, model these entities, not the rest. So we had to draw a line. If you look at the light blue entities in the model, there's many more, okay? And relationships. There's plenty of relationships, but we had to cut because we have to deliver in a short period something that is useful concretely. So today with this, we can exchange data, Crossref, DataSite, OpenAlex, common data that they have using the same identifiers. I think it's a brilliant result if we can in a year, right, do such a thing.
Right. Hi, I'm Jun Lau from NIST. I'm just wondering, so suppose that my institution is ready to embrace fully the PID infrastructure. So is there like a starter kit that somebody might use?
Well, you can live with these guys for a while. And
You can live with me, but I mean, many of my colleagues that work in engagement are how to help you to start with a persistent identifiers can help you throughout the call. I mean, everything is about using PIDs in all your workflows, but you are sitting just next to one of them. So
there's plenty of persistent identifiers. There's another foaming one at the end of the room on the instrument. So oh, sorry. Yes.
Yeah, I wanted to make a comment on. Can you hear me?
No, it's for the online people. It's for the online people.
Okay. Yeah, I wanted to make a comment on personal identifiers. So orchids are nice, but orchids are for living people, and others do not live forever. And we have publications that are hundreds of years old. So the authors for sure do not live anymore. So I would suggest to also consider, for instance, including a Wikidata ID, because a lot of these authors have one.
We are agnostic of the ID, so it can be any ID. We are not fond of DOIs only, but we take DOIs as any other ID for any other entity. So the model is designed.
Not only orchids.
Yes, no, not at all.
Yeah, I'm Maggie Hellström from ICOS Carbon Portal. I was just curious about who are the users of these graphs? How can you break that down into those doing analytics on it? For instance, funders who are going out and verifying what researchers have said in the grants, people who, individuals who want to go out and look at where do I fit into this thing? And finally also, I mean, for instance, people who want to do research on the research that is captured by the, but what is the percentage of all of those? And does that influence which nodes and edges that you include in your model to make those kinds of activities really viable and effective?
Sociological question.
Yeah. Wonderful question, really. I think all the use cases that you were mentioning, they are all valid ones. The one I feel closer is the science of science, research on research thing, but I think that's the minority. Yes, you can do landscaping, you can do partnership scouting, co-author scouting, charting topics, finding plenty of things. And you can do these as a final users because you are interested in checking your own area of research, or you could do that as a practitioner of science of science. And of course, as you were mentioning, the kind of research questions that you are, or just questions that you are trying to answer, drive requirements on the data. Like scientometrics is full of research questions on citations, and not having citations within an SKG, it already cuts you out from being viable for this kind of uses. And what I'm trying to push for in these months, it's like try to foster the switch to open scientometrics and open science of science. I'm going to have, I mean, we submitted at the ISSI, which is going to be in July at Indiana University, Bloomington, a tutorial on, which is going to be based on the OpenAir research graph. And well, actually now it's an OpenAir graph, full stop. But so to show the people that are working on scientometrics and science of science, that's actually possible to achieve things using open data sources. Because at the moment, the whole community, the whole research community is stuck with Web of Science and Scopus, which are great, but they have a very peculiar snapshot on the research environment, which is partially, it captured the whole thing in a partial way, because there's a bunch of other things ongoing that are not actually parts of the data they expose. And the other thing is that it affects reproducibility and validability of results, because they can't, by non-disclosure agreement, they can't share the data the research is built on, and that, you know, like it's a flow. And yeah, so yeah, I mean, it's a wonderful question. Yeah, I don't know exactly which are the percentages, like how we can what is the use case that it's more fed by this kind of data, but they are all equally important, I would say.
Yes, I wonder indeed also what not just the uses, but the use case that you would like to address. I mean, if you want to address all use cases, that seems rather impossible. But if there's a selection of use cases, then it would make clear what the choice of the model implies. Because in general, you know, if you come to a common model, you run the risk of having the least common denominator of all that information that's out there. On the other hand, that model could also be used to reference all the information sources and link them together, deduplicate them, and as such be you know, a very useful tool to collect all the information together and link them together. So could you elaborate a little bit on that, you know, what you ultimately try to achieve with this? Because we love the value of the
focus
information that's in the original sources. We rather not lose out on parts of it.
Yeah, no, I get it. The things that what you're saying is true, that we are not doing that with a specific focus in mind. This is true. Like we are trying to factorize what is around, and these mean that you might have certain use cases that are left uncovered by putting things to common denominator. The thing is that we try to, because we try to engage with major players, and having major players in the loop in all this process, we believe that all the most important use cases and applications are going to be served by whatever we achieve. So it's we work rather than starting from the problem and then thinking about how to model the common model, so to target that problems. We work like the other way around. We start from people that are doing real work and solving actual problems with their own data, and try to find something common. Then most probably, like most of the problems that they are able to solve will be piggybacked in our solution. I mean,
I might add something.
Yeah.
I mean, and probably within the scope of the PID graph, I think I mentioned there are some things that are out of the scope for us, but the way that we do have some specific use cases, and basically every time that we want to cover more of what the task force are doing, of the use cases of all the open science graph, they are there. We prioritize based on the specific use cases that we have. I mean, one example, we work in this project called Make Data Count. They are looking to see how citation is affected by the age of the researcher. We prioritize certain development and certain parts of this work based on that. So we do it in that. I mean, particularly in the scope of that, we go that way, if that helps.
And Paolo, something that the other thing is, we are not. I mean, here we are not pushing for the tagline of this whole activity is not like, let's ditch that source in favor of this one. It's let's find some common language so that you can enhance your source and add certain add information coming from other places into your, which means that all the applications and case studies that you target already, I mean, they will stay with you. It just with this, you would just benefit from this delta of information that comes from other sources that you didn't have, and that you can benefit from to solve the applications you're already engaging with. Like Scholar Explorer, it provides links between literature and whatever is not literature. If you model just literature and you already have a core business in that, and you get paid, that's Elsevier application. But still profitable for them to come at our endpoint, get the links, so that it's more information, and they can build new services on top of that. Still, all the other questions answered, they go with them. It doesn't. It actually, it's an opportunity to have more. So, yeah.
In general, anyway, you're an SKG provider. To build an SKG, you need to collect information, and you're already struggling with that because of the multitude of heterogeneous sources. In building practical problem, building a graph like OpenAir, we have to collect from DataSite through APIs, which we have to learn how to use in terms of format, in terms of deltas, in terms of refresh of data. The dump that you're going to build is going to be very useful. Then Crossref, then try to download Microsoft Academics and make a graph out of it. It's a bunch of tables, right, with very specific formats, and the format may change, right? They may send you an email saying, well, like, now it's over, it's no longer there, we have OpenAlex. But again, to build such systems, you have to cope with this major heterogeneity problem and its evolution, okay? So it's a very different story instead if you agree at least on a reasonable way to share data. Then, of course, other problems will appear, but a large chunk of them will be over. So, and this is extremely important, I mean, for those who are providing these kind of services.
Paolo.
Thanks. Stephen Keckman from the Australian Data Archive. I've actually been working with Amir and Peter Vatz, actually. So as it turns out, I'm both a producer of information and a consumer of information. We're doing two different projects within that. So what we're learning from that is actually how to reinforce and continue to build the graph by embedding certain things and populate back. And we've actually done some work. I was sort of expecting it might pop up in Amir's presentation. Just a quick reflection on that from work that we've done. Is I think you've got projects modeled wrong as well. And the reason being is you had, was it research objects were being funded by projects? No, they're not. They're funded by grants. Yeah. So just, yeah. Yeah. So the point being though is, I mean, say we've established RAIDs, so anticipating particular things that certainly are emerging. Say, I think would be, and you already have grants in there. I think that's probably just a space to be putting in there, but kind of anticipating, there might be worth some effort, particularly on projects in the short term, to see where they might be going, given that the sort of the RAID infrastructure is now starting to be built out as well.
But I think it's just a matter of language.
Okay, I think I'm going to ask a small provocative question.
Please do. These are the ones that we prefer.
But I have a loud voice. Don't worry. No, they can hear me. For me, I just wonder why you call all these graphs, because for me a graph is something in which you're walking through, and it's quite the end. But I did not hear anything about the algorithms you're using for walking through the graph. There are many algorithms. Some are more efficient than others. And for me, these are only simple models that you're using for providing kind of abstraction. So why are you calling them graphs? Because graph is a really mathematical, precise world.
But they are. That's why, because conceptually
I haven't seen anything like.
Wait. So let me explain first. So, if you look at DataCite as a collection, if you actually try to access DataCite, let's say 5 years ago, it was a collection of records. Okay, you could have called it a collection of records, a flat collection of records, but in fact, it wasn't already at that time, because when you take this collection, it's just the physical representation of a graph. Why is a graph? Because you have clear entities with a type, an identifier, and you can point to them. You can build references. So a record, de facto, is one entity with pointers to other entities. The fact that you represented it as a record is just a physical representation of a graph, or a subgraph that connects. No, it's mathematically perfect. So you can call graphs anything that is a representation of identifiers linked with each other. You can have the notion of type of these identifiers. If you want, these entities can have something in common. Sometimes they don't. The way you represent them in your storage is a completely different story. You may represent them with using graph-like engines, so you can browse through them. You can represent them in a flat index. In what we do in OpenAir, for example, is physically we represent them as nodes and links into a cluster. It's a SparkQL cluster, but then the same graph is represented in an index, and there doesn't look like it, but it is. You can browse through the objects in a linked open data. Now we dismissed it, and in many other forms. But it still is, conceptually speaking, the information that you are storing is graph-like. So it doesn't matter how you store it and how you consume it. This is a different thing. Like now, for example, DataCite decided to have a GraphQL interface because they wanted to give a graph perception of this collection. And now you can also browse through it using different tools that are more graph specific. But ideally, they're all graphs because they represent connections or networks of objects and semantically related.
Yeah, but my question was very precise. What algorithms are you using?
But again, it depends. This is a problem that is out of the scope of this project. Okay, you have once you have a graph, you can use all sorts of algorithms to enrich it, to query, to search it. Doesn't matter. It depends on the technology you're using. If you have a graph stored in a relational database, you build your SQL query to browse through it. If you have it in a GraphQL, in a graph-like database, you write a SparkQL query. But it depends on the tool you have to store your graph. But storage is at a different level. Okay? Conceptually, what you're doing and representing is this notion. And this is why we call them like this, because we want to be independent from the storage format. Okay, so 5. Another question? We clarified all your doubts because we have so many. So let me close like this. So thank you very much. All the questions were great and actually pointed out where we are not clear, where we should be more clear, and where we should actually further investigate. Thanks to Tommy and Keith for the, let's say, reshuffling a little bit the cards. And so we go through again and find this, if this line is clear or not. Thanks to all of you. And please participate, be proactive. You know how to reach us. You have all the links. We have also established a separate list for those who want to be proactive and participate. So send us an email. We have further meetings beyond the one of RDAs, which of course we send out using the interest group mailing list all the time. But in this mailing list, we have other forms of conversation because, as you know, the RDA allows us to send out an email. It's a one direction thing. So there's no conversation that can take place there, right? So please contact us if you want to be proactive, especially the providers online and physically present, because your input is extremely, extremely important. So thank you again. Thank you, Andrea. Thank you, Christian. Thank you, Amir. Thank you.